All right, now we're going to look into supply and demand. So basically combining what you've learned in these sections on consumer demand, flipping that for a supply side, and figuring out how markets work, as well as adverse selection, basically the failure of markets under certain conditions. So what we've done so far, as you know, we start with consumer demand and cost analysis. We're going to have a lot to say about this, and we're going to relate back to it. Segmented pricing, not so relevant for today. Now we're going to talk about supply and demand and adverse selection, as I said. Next section is going to be on game theory and auction design, a little more tricky potentially. And last, we're going to wrap up with agency and incentives. So being at the halfway mark, let's talk about supply and demand. When talking about supply and demand, we're going to talk about markets. I think the most common market to think about for most of you, since you're in New York, is probably the stock market. That's a classical, canonical almost example of a market where people buy and sell shares, obviously. A market is, simply put, a place where buyers and sellers interact, they meet and they trade. A buyer, as you know, has a willingness to pay, the sort of imaginary value at which, if the price is below that, they want to buy a product. And as you can see here, buyers buy if the price is indeed less than the willingness to pay. The seller has similarly the sort of imaginary value that they attach to a product that they want to sell. But since they're not buying but selling, the price, obviously, the money that they receive must be higher than this, what we're going to call willingness to sell, or WTS. The market price then is basically a single price at which all transactions occur. Again, using the stock market as an example, basically, not every transaction, but like pretty much, simply put, the transactions that happen at a given instant all occur at the same price. Different markets that we think about often are commodity markets, be it oil, be it coal, be it bushels of red winter wheat. All these usually have a fixed price because there's all the suppliers coming in with their supplies, all the buyers bring their demand to the market. Ultimately, there's going to be a market clearing price at which everything is going to be sold and the products are going to be allocated to the buyers. This only works if we have what's called a competitive market. You haven't seen this in lecture, I think. It basically just says that the products must be substitutes, so they basically must be quote-unquote identical. There must not be any switching costs between producers. If I'm the buyer and I want to buy a product from a supplier and I have huge switching costs moving from one to the other, then this is not really a competitive market. I have a lot of incentive to stick with my current supplier because that's what minimizes my cost, right? Even if it's cheaper to buy from another company, if it's like really expensive for me to make this switch, I'm going to stick with a higher price. That's not a competitive market. There is no information asymmetry. That means I have the same information as the person selling it to me, and we're going to see what happens if that's not the case when we're talking about adverse selection. And ultimately, there's perfect competition. All of you can perfectly compete, if you're the sellers, with me, with one another, so that I can basically choose freely among you, and I don't really have any benefit of going with one over the other. And that just ensures that the price for all of you is going to be the same. It's going to be the competitive market price. And all of this really just gives us is that supply and demand curves can be what we're going to call aggregated. This basically means what we've done all along and assumed with the demand curves, that we can add up people and figure out what the demand curve is that way. Technically, we were assuming this all along, that we have a competitive market, that the products everyone buying are in fact identical, that whoever is supplying them, that they're competing with one another, and so on and so forth. What we ultimately want to find, and this is something that's very common in economics, is what's called an equilibrium, sort of like this one point that naturally arises. If you want to think a bit more economic history, the invisible hand is sort of one way of like describing this. It's like if we have people interact in a market, there is going to be one price at which everyone happens to trade, one quantity that is going to be exchanged. And these prices and quantities, which we're going to call P star and Q star, that's something economists really like, putting a star to things that are somewhat special. This is what we're going to call the market price and the market quantity. There's just the one price at which the quantity that's demanded equals the quantity that's supplied. Simply put, if you were thinking about a demand and a supply curve, as downward sloping is demand curve, upward sloping a supply curve, which just says at which price does a buyer, or do the buyers want to buy what quantity, and similarly, at what price is a certain quantity going to be sold by the sellers. Where they intersect naturally, that's the point where supply equals demand. That's where we have the market price and the market quantity, and then if you plot them in a problem, you can find the equilibrium that way. We often talk about market efficiency in economics. It's more of a normative statement. We generally like to think that a market is, in fact, efficient and the best way of allocating goods. The reason why is basically the person with the highest willingness to pay gets to buy the product that's insured in a market. So whoever values the product the most and sort of derives the most value from it, that's the one who's going to be allocated the product. Whereas similarly on the flip side, where we look at the producers or sellers, the one who has the lowest willingness to sell, which you can think of this as being the most efficient producer. If they have a low willingness to sell, that means that it's really cheap for them to produce this good. They're really good at producing the good. Those are the first ones to sell. And ultimately, sort of when we think about value, it's the area under the curve, or technically the area between the demand curve and the supply curve, this sort of wedge, that is maximized in a market where we derive the equilibrium that way. So we generally like these competitive markets. That's why we like the stock market. That's one argument people brought to the table and saying, well, it's good that Uber is around because now there's competition with cab drivers, and maybe we get closer to, competitive market, even though that probably wasn't actually the case ex post. But, as these things go. If we want to solve a problem like this, it's very, very, very similar to what you've seen in the general consumer demand setting that we covered in the beginning. We start usually from the demand side. You can start from the supply side. It doesn't matter. You sort all potential customers with willingness to pay in descending order, what we've done all along, right? The notion being whoever has the highest willingness to pay should be the first person to buy. Then if there are multiple consumers or customers with the same willingness to pay, we group them. It's just like sort of happens that when you're given a table, they appear a couple times, so you need to make sure that you get the grouping right. And then we derive the demand curve, which simply relates quantities to prices, right? And that's like half of the job done. Then we do the same for the supply side, but since supply is sort of like the mirror image, we sort sellers by ascending rather than descending willingness to sell, right? Whoever has the lowest willingness to sell, who's the most efficient, should be the first to sell. We make sure that we pool sellers with the same willingness to sell, and then derive the supply curve, which obviously relates prices to quantities, but in terms of the supply rather than the demand. Finding the equilibrium then is actually quite simple. There are two ways to do this. Either you just look at the tables we're going to create and then find the price and quantity where the price is equal and the quantity is equal. That's the definition of the equilibrium. This is the definition of the market price and quantity. Or I would not recommend doing that, but I'll show you how that works as well. You can plot the two things and see where the curves intersect. Since you need the tables to do the plots anyway, first option should be preferred, but you can do the other one as well. So let's go to a quick example. This is on potato farming. And the market for potatoes, same as basically for all commodities or commodity-like products, is highly competitive. The price is determined by demand and supply, and there's just like a bunch of statistics on the potato market available. We're basically going to be given a table of the willingness to sell of sellers in the US and the willingness to pay of buyers. And then we're going to try to find the equilibrium. That's question one. And then we're going to suppose there's also going to be imports coming from abroad. We're going to suppose that due to tariffs, these imports fall by 60 units. And we're going to want to try to figure out what happens to the equilibrium. What happens to prices, what happens to quantities. All right, this is the data we're going to work with. So here you have the first table with the producers, second table with the consumers. You can see already that several willingness to pay and willingness to sell appear repeatedly. So there is some of this like aggregation that we need to do. The way we start, let's start with the producers here. We're going to take all these willingness to sell, but we need to make sure that they're unique. Since we're doing this in Excel, it's pretty easy. You just copy them over into an empty column, go to data, and then remove duplicates. It's going to ask you where you want to remove them. I'm going to say column M, and if we remove one duplicate, that's what is a 0.5 from the top, and now these are indeed unique. We're going to plunk them down here as prices, since we know ultimately this is what they are. And now we need to find what quantity is going to be sold at this price. If the price was to be 0.5, how do we find the quantity sold? We're going to use a function that's called SUMIFs. we're going to say, well, we want to sum over all the quantities by the producers that are willing to sell at exactly this price. We're going to do at first, then add up things later. And we want to do this under a condition, a criterion here, which is the willingness to sell. We're going to, again, make sure this doesn't move when we're dragging down the formula in a second. And we want to make sure that the willingness to sell for these people that we consider is equal to this 0.5 and A33 here. So what did this function do? Well, it just computed all the quantity available by suppliers that are willing to sell at 0.5. Now we can just drop this down for all of them. Everything else is unique, so it's just 2 for each additional 50 cents. But this is obviously not the aggregate. This is like how many units are, how many sellers have, sorry, how many units are going to be sold by sellers that have a willingness to sell of 1. This is not really the quantity that's going to be in the market. To get at the quantity that's in the market, what we need to do, we basically just have to take the sum going down the table. So we're going to make sure that we're basically taking this into account. You're going to see, right, at 0.5, quantity is 126. At 1, it's 126 plus 2, 128. At 1.5, it's the sum of these 3, which is 130, and so on and so forth. Should be pretty easy, pretty straightforward. Now we're going to do the same for the consumers. Again, we're going to make sure that these prices are unique. We're going to remove all duplicates. There we go. And then we're going to copy those over into this table that we're going to use for the quantity demanded, hence QD. As I said, we have to sort them in descending order, right, from largest to smallest. We want the person with the highest willingness to pay to be served first. We again use the sum-ifs function to find out how many people have, or how much quantity is associated with a willingness to pay of 9. Again, we're going to take the sum over this column, making sure that we're not going to miss out on anything when we're moving this. Criteria, again, are going to be the willingness to pay. And we want this to be equal to the E33 cell. This is the 9, the price of 9 here. So we know that in total, quantity of 4 is associated with a willingness to pay of 9. We can drop this down. It's 10 for all the others. That's fine. And then the total quantity demanded, again, is just the sum over these things, and making sure that we anchor it in the beginning so that it's really reflective of the whole thing. And here you can see, as again, it's just like these 2 make that, these 3 make that, and so on and so forth. Okay, so now we have a supply curve, we have a demand curve. What we want to do next is check where the 2 intersect. So we're going to take the prices from here and drop them here. Since the market price has to appear in both tables, we can either use that list or this list, and it doesn't make a difference. We're going to check what the quantity supplied is. How do we do this? We're going to use a VLOOKUP. What this does basically says, look for this value, the price of 9 in this case, in this table. And again, making sure that we don't change anything when we're going to move this formula around. And this specifically return the 3rd column, right? We're going to search in the first, this is always the case, but we're going to return the value from the 3rd column, and we're going to supply false, which means we want an exact match. We drop this down here, so we have all of these. You can compare that 1.5, 130 is exactly this value here. And now we're going to do the same with the other table. Again, we're going to look up 9. We're going to look it up in this array over here. We want the 3rd column, and we want an exact match, so it's false. And then we just populate this. Now the question is, well, what is the equilibrium? We said the equilibrium is the sort of the quantity demanded equaling the quantity sold. This here is at a price of 2.5 and a quantity of 130. This plot that I created, not really pretty yet, but seems to have missed something about the demand, as you can see. Well, now it got it. Well, Excel being Excel. Now you can see another way of finding the same solution is basically plotting these two lines. This is a demand curve, this is a supply curve, very simple straight line one. And we can see here the point where it's 134, 2.5 is where they intersect. Found this the same way. Now, next we're going to say, well, there's these tariffs or import restrictions, and that reduces basically this import here from 124 to 64. What we're going to do, rather simplistically actually, we know that everything else stays the same, so I'm just going to subtract 60 here, right? Because I know that that the 0.5 column is where the imports fall, so I just subtract 60 and it's fine. Of course, we kind of just move this stuff around, so I'm making sure that everything remains where it should be, fixing the formulas along the way. Oh, sorry, that was my mistake. It's obviously going to start here and extend downwards. So now we have our new supply curve. Demand actually does not change, but for the sake of the argument, we're going to do the same thing again. We know where this comes from. We know where these things are computed. This we then obviously need to fix, again, since we want to make sure that it only starts up there. Plunk the stuff down here. Sorry. And there we go. Supply demand curve, we can see they intersect already over here. Let's again compute a little more, in a more sophisticated way maybe, what the actual supply and demand at these values are. I'm going to take this table here. We're going to again get the third column with an exact match. I'm going to plunk this down. We're going to do the same for the demand. There we go. Third column, exact match. Drop this down there, and this time, there's already a bit of color there. We can see quantity where the two intersect is a quantity of 84 and a price of 5. So what have we seen? Well, first of all, price has doubled. Seems like what we've seen over the past couple of weeks and months, maybe, and quantities fell. And if you compare these two plots, you can see that basically what we did is we shifted the supply curve to the upwards and to the left, and that obviously means we're going to move quantities down and prices up. And this is exactly what we find. All right, this was what I have on supply and demand. It's really not, I don't like the expression much, but it isn't rocket science, right? This is fairly simple stuff. What we're going to come to now is, I think, a little more interesting. Hopefully, this is adverse selection. Basically, we're now going to deviate from the notion that the market is perfectly competitive, that the buyer and the seller know the same thing about the product, and now one of them is going to have more information than the other. Talking about information, in this context, there are basically 3 different types of information or definitions of information that might be relevant. We've so far dealt with what's called perfect information. Basically, all participants know all relevant information. So this is a very, very strong notion. Basically, everyone knows everything about the product and the price and how everything happens and comes along. This is sort of the best case benchmark, right? What we often see instead is what's called symmetric information. This is also sufficient for most of what we did, that would work as well, in which the participants know equally much. So the buyer and the seller both know the same thing about the product. So if the product's broken, that's something the buyer didn't know, but the seller didn't know either. What we're going to look at today is a lot more involved. Basically, it's asymmetric information. That means one party knows more about the product than the other. Usually, we're going to assume that the seller knows more. You could turn it around if you like, even though that's usually not really interesting. So we're going to stick with the seller knowing more. Specifically, we're going to think about a setting where the seller knows whether the product is good or bad, but the buyer does not. And this sort of this asymmetric information then gives rise to a huge bunch of problems. I mean, there is a reason why you would like to buy a used car from a dealer, right? You think the dealer is going to somehow be able to make sure that the car is good. There's a reason why if you want to buy an expensive watch on eBay, eBay offers an eBay guarantee. Basically, the watch is going to be sent to an eBay certified whatever watchmaker person, who's then going to make sure that the watch is indeed genuine, that it works, that keeps time, and so on. So that is something that's like very common. So since we are so concerned with this, it's important to learn about like what happens if there is adverse selection. Adverse selection generally means that because of this asymmetric information, the quality of the goods in the market falls. You're going to see why this happens. Usually we think about there is good and bad products being sold. It's basically on the surface the same product, right? It's a used car, say, but it can be good or it can be bad. And because of adverse selection, all the good car owners are not going to sell them, and then that basically leads to only bad used cars being sold. That's the canonical market for melons example that Akerlof came up with. If you want to Google that, you're going to find a bunch about this kind of problem. In the future, and in the last week and the last session, we're going to talk about moral hazard. It's a similar form of asymmetric information, but in a different setting. This is when you, say, employ someone, but you cannot observe whether that person is actually working hard or not, because it's hard to observe, and sometimes people just get unlucky. And what happens in these settings is what we're going to think about a lot more towards the end of the course. There are generally two types of equilibria in terms of just like getting the wording right. Generally speaking, we talk about pooling and separating equilibria. In a pooling equilibrium, every type, usually we say, in the case of the market for lemons, it's the type is the seller of the car, can be a good, can be a bad guy. And when we think about pooling equilibria, everyone behaves the same way, whereas in separating equilibria, people behave differently. You're going to see how that sort of fits into the problems that we're going to talk about in a second. The way to identify these questions is pretty simple. Usually it's set up in a way that the buyer doesn't know the type of the seller, whether it's the product quality, the skill of the employee, and each seller has a different willingness to sell. Sorry, I wrote willingness to pay here. It should be willingness to sell. But also the buyer has a different willingness to pay for the different products. And usually the willingness to pay depends on the unobservable type, right? It could be, if it's a good product, I'm willing to pay more than if it's a bad product. If I know it's going to last me 10 years, I'm willing to pay much more rather than if I know that it breaks after a day. The way we solve these products is usually, since there's a distribution of sellers, first we start by computing the sort of expected willingness to pay. I'm going to show you how this works. We're just going to weight the willingness to pay of the buyer by the proportion of the sellers of the different types on the market. Then we're going to create a table with all possible price ranges based on all values of the willingness to pay, the expected willingness to pay, and the two willingness to sell. We're going to compute the producer surplus at any given price for the two types of producers, and then identify how much each individual is going to be willing to sell, and therefore what the market quantity is going to be and what the composition of quality in the market is going to be. Then we're going to, since the consumer here is sophisticated, so they know how sellers decide what to sell and what not to sell, or when to sell, when not to sell, even though they cannot observe the quality of the product outright. And then we're going to use that sort of notion to compute the consumer surplus in all of these cases, and based on the products in the market. And then we just find the equilibrium as we did before, where quantity sold equals quantity demanded. So let's jump right into this very, very famous problem, which is called the market for lemons. In this, we say we have 25 potential used car buyers, each of whom is willing to pay $1,200 for a good used car, or $400 for what Akerlof calls a lemon. Potential buyers will buy at most one car. This is just to ensure that quantity is well defined and demand is well defined. But before they purchase a used car, they are not able to tell whether it's a good or a bad one. And once they've bought it, they cannot return it, obviously. What's important are, as usual, the numbers. Most of these words are actually kind of meaningless. Don't let yourself be led astray by them. Here, the important part is that the current owners of the good used cars have a reservation value or reservation price or willingness to sell. It's all the same concept of $700. Below that, they're not going to sell. And the current owners of the lemons want at least $200. there are 5 good used cars and 15 lemons. Obviously, at prices below 200, the lemons are not going to be sold, and all the other stuff is basically irrelevant. Let me briefly highlight the things that we really need in order to solve the problem, namely the willingness to pay of the buyer or the buyers, $1,200 for a good used car, $400 for a lemon. The reservation price is $700 for the good, $200 for the bad, and how they're composed in the market. There are 5 good used and 15 lemon cars. That's all we need. The questions we're going to ask ourselves are, firstly, we're going to try to find the equilibrium price and quantity in this market. Then we're going to try to change up things a bit and say, well, what if instead of 5 and 15 we had 10 and 10? How does that affect the market clearing price? And I'm going to skip the profits, but you can compute them from what we're going to do pretty easily. And lastly, if a mechanic is moving to the town of question 1 and then offers to certify cars for $100 per inspection, how will this sort of affect what we're going to see in the market? So we're going to go to this example here. I already set up the tables. You can use them in this way. As I said, what we're going to start with is sort of this expected willingness to pay, which I'm going to call E of WTP. How do we compute this? Well, we know there's 20 cars in the market in total, 5 of which are good. So 5 out of 20 are good, and we're willing to pay $1,200 for them. And there are 15 cars out of 20 that are poor, and we're willing to pay $400. So the expected willingness to pay, if everything was to be sold, would be $600, since we cannot distinguish between the good and the bad. So the prices we need to consider are basically $200, that's the willingness to sell of the lemon owners, $400, the willingness to pay for a lemon, $600, this expected willingness to pay, $700, the willingness to sell of the people owning good cars, and $1,200, the willingness to pay for a good car. We're going to do this always in the same way. We're going to consider different price ranges. We're going to start with what if the price is less than 200. The next one is what if the price is equal to 200. Then what if the price is greater than 200 but happens to be less than 400? What if the price is equal to 400? What if the price is is greater than 400 but less than 600? What if the price is exactly 600? I've got a bit of an OCD thing going on here. I want yes. What if the price is between 600 and 700? What if the price is exactly 700? What if the price is between 700 and 1200? What if the price is exactly 1200? And what if the price is above 1200? This is a bit overkill sometimes doing all of these cases, but it's guaranteed to get you to the right solution, so why not do it that way? So if the price is less than 200, we know that the lemon owners are not going to be willing to sell because they want at least 200. So there's no lemons in the market. The good car owners, they will not sell either because they want at least 700. So none here. The quantity supplied in total, therefore, is 0. At exactly 200, the owners of the lemon cars are indifferent between selling and not selling. So every individual one might sell or not sell and is sort of equally well off. The way we're going to think about this here is that the quantity can be anywhere between 0 and 15. Right? Because they're indifferent, so selling, not selling doesn't make a difference. There are 15 of them, so quantity is going to be somewhere in that range. The good quality car sellers are obviously not going to sell because they have no incentive to do so. They still want 70. So the total quantity, again, is going to fall between 0 and 15. For all prices between 200 and 400, exclusive, all the lemon owners want to sell. Because they have a reservation price of 200, so if the price is above that, strictly above that, they make positive value, and therefore they all want to sell. So we can use these columns here, the surplus columns, to actually get at this notion, namely the surplus of a lemon owner is always going to be the price minus the willingness to sell of 200, which in this case is less than 0. In the second case, This is exactly 0. That's what we used to say, well, quantities can be anywhere between 0 and 15. And for all higher prices, this value that they capture is greater than 0, so they want to be selling all of them. And this actually applies to all columns down here. Similarly, we can do it for the owners of the good cars. They are going to have a reservation price of $700. So this actually, the difference between the price and $700 is what matters to them. And as long as that is negative, as it happens to be for a long way down here, and we're going to talk about how this goes on in a second, they're not going to sell anything, right? So using this, we know that for all prices above 200, all the lemon owners want to sell all their cars, so there's always going to be 15 of them. And at least as long as the prices are less than 700, all the good car owners are not going to sell anything, and the total supply is 15. At a price of 700 exactly, the surplus that the owners of the good cars get is 0, so they are all indifferent between selling and not selling. So the quantity that they're going to sell is anywhere between 0 and 5. So the total quantity in the market is between 15 and 20. At all higher prices, the surplus is strictly positive, which means they all want to sell. So there's always going to be 5 good cars in the market, and total quantity sold is going to be 20, and this sort of applies down here as well. You don't need these columns, this surplus stuff. It's just like sort of rationalizing why certain things, certain quantities are going to be sold in certain situations. Now, since the buyer is sophisticated in the sense that they know this, all of what we've done now, the buyer can figure out as well. So they know what kind of car is going to be in the market. Let's, for a second, skip the first row because it's very difficult to make any sort of logical argument here. But so if they see the price is 200, if the buyer sees the price is 200, what's going to matter is obviously their willingness to pay minus the price. And whether this, what kind of size that has. What we're going to find is that at a price of 200, this is going to be strictly positive. Why? Well, the willingness to pay is whatever the composition of cars in the market dictates. There's only bad cars in the market at the price of 200. So what is the buyer willing to pay? Well, they're willing to pay $400, namely their willingness to pay for a bad car. They know at a price of 200 the car is going to be bad, but it's still fine. Like they were willing to pay 400 for them, so that's good. Since the consumer surplus is positive, that means that everyone is going to demand a car, so demand is going to be 25. The same actually applies for all prices that are strictly less than 400. At a price of 400, there are still only lemons in the market, so the willingness to pay is 400. But now the surplus is, since the price is also 400, the surplus is 0, and they're indifferent between buying and not buying. So the quantity they're going to demand is anywhere between 25 and 0. For all prices where there's only bad cars in the market, it's still the willingness to pay is 400, but now the surplus is negative, right? They know at all prices, basically between 400 and 700 exclusive, there's only going to be bad cars, but they're not willing to pay more than 400 for them. The prices are above 400, so they're going to demand 0. Now we're going to look at the interesting cases where the good cars entered the market. If they were to observe a price of 700, they would know that, and then we're going to be rounding a bit here, they're going to know that, well, best case, there's 15 bad cars and 5 good ones. What is the willingness to pay? Well, there's 5 out of 20 are good, and we're willing to pay $1,200 for them. And 15 out of 20 are bad, and we're willing to pay $400 for them. So their willingness to pay in this market where both of these cars exist is $600. But now, willingness to pay 600 minus the price of 700 is still negative. So they're still going to demand nothing. And actually, this applies to all higher prices as well. We can drop all of this down here, and we're basically done. So what we've found is, well, we now know the quantity supplied, the quantity demanded, we know the prices. So now it's basically finding a row where the quantity supplied and the quantity demanded is equal. And it's very easy to see, well, not really equal, but like close enough in the sense that if the price is 400, there are 15 that are going to be sold, somewhere between 0 and 25 that are going to be demanded, and this matches nicely. That's the equilibrium we find. And if you want to plot them, the way we generally go about this is you basically enter every number of all the points that you're considering twice. 600, 600, 700, 700, 1200, 1200. Well, in order to make it look nice, actually, let's make sure that the first one is a 0. That just anchors things. We know that the price of 0, supply is going to be 0, demand is actually going to be 25. We can use this here. This is just the notion of if the price is less than 400 actually, and something is going to be sold, well, they're willing to pay 400 for anything. So if the price is less than 200, they are willing to buy whatever it is that they're buying. And now we know that at 200, it's between 0 and 15. We're going to spread this out over separate rows. At 400, and we're going to look at this column here, actually, the QS. All the way up to 700, it's going to remain 15. So we're going to keep those. At 700, we're going to have between 15 and 20. So we're going to enter 15 in the first row, 20 in the second. And it's just going to remain 20 for the other ones. Similarly, we're going to look at the demand. It's 25 up to a price of 400. So we're going to keep 25 all the way down here. At 400, it can be between 0 and 25, so it's a 0 here. And all the other ones, demand is going to equal 0, so we're going to plot all of those here. And the plot you can see on the right-hand side should be fairly familiar looking. This is exactly what you did in the class when you have these like sort of kinky kinky demand and supply functions, and you can see where they intersect. That's exactly at a quantity of 15 and a price of 400. That's what we found as the equilibrium previously as well. Now, in the next step, we're going to say, well, what if, grouped columns. What if instead of having 15 bad and 5 good cars, we're going to have 10 and 10? Well, this sort of the expected value, if everything's going to be sold, is now 10 over 20 times the $1,200 for the good car, and the same at 400. It's basically an equally weighted average. So now we don't have to consider 200, 400, 600, 700, 1200, but we're going to have to consider 200, 400, 700, 800, 1200. So let's quickly change the table where it needs to be changed. We no longer have the 600 one, that becomes 700. This is also going to become 700. The 700 becomes our 800. Price becomes 800 here and here. Everything else is the same. Now let's look at the quantities and see how they change. We're going to start again with the quantities for the supply side at anywhere between less than $200. No lemon is going to be in the market. That still remains the same. They all remain the same. For the good cars, we know at below 700, nothing is going to be sold, so we know that this changes. At 700, we had the same rationale as before, namely that the surplus is exactly 0, so the quantity is going to be anywhere between 0 and 5, total quantity between 15 and 20. And for all higher prices, all the good cars are going to be sold, or at least available in the market, let's say. And therefore, for all these prices, the quantity sold is going to be 20. Now, let's jump to the willingness to pay. Well, it's still when there's only bad cars in the market. So for all of these cases, it remains at 400 for the same reason as before. However, when there are suddenly the other cars in the market, we're going to say, well, half of the cars, 10 out of 20, are now, in the best case scenario, high quality, and 10 out of 20 are lemons. So we get this 800 willingness to pay that we know from before. And now we just compare the prices and the willingness to pay again. What we see is that at this, in this row, the willingness to pay is 800, the price is 700. So there's actually, the surplus is in fact positive. So they're going to be willing to buy exactly 25 cars. The same holds for the row below when the price is between 700 and 800. And but only once the price is exactly 800, we're going to find that they're indifferent between buying and not buying. So the quantity is between 25 and 0, and then sort of like remains at 0 thereafter because the difference between the price, the willingness to pay and the price is negative. Now we again look for the equilibria. We're going to compare quantity sold, quantity demanded. We still have this annoying equilibrium where only bad cars in the market are going to be sold. That one we cannot get rid of. But we find that there's another one, namely down here, where at a price of 800, where at least everything is going to be sold. Which ones we're going to observe, that's very hard to tell. These problems are not designed to figure out, or it's impossible to figure out which one's going to happen, either one of which can happen. Now let's plot. We're going to again do the same thing. We're going to enter every point, price point twice. 700, 700, 800, 800, 1200, 1200. We're going to get the supplies. This is just this column here, right? At price of 0 at 0, at a price of 200, it's between 0 and 15. And the next time it sort of bends is at 700, so it's going to remain 15 here. At 700, it can be 20, and then it remains at 20 thereafter. The demand, again, we know from the beginning, it is 25 at all prices up to 400, then it goes down to 0. However, at 700, we can actually have a positive demand of 25. So we're going to enter this here, and then we know that for all prices up to 800, it's going to remain that way. At 800, it's going to fall back down to 0, and it remains at 0. You can see I plot this here as two separate curves, the quantity demanded when there's only lemons in the market and the quantity demanded when there's both. We can see there's this one equilibrium down here and the other one up there. All right, and last but not least, we're going to look at a case where a mechanic is moving to town and where he offers to certify cars for $100 per inspection. And I'm going to take a shortcut here. You can show more formally that there's going to be a market for certified good cars and for uncertified lemons. Why? And the reasoning is simple. Since the certification reveals the type of the car, we're going to assume that the mechanic can figure this out and actually reports truthfully. If a lemon owner who knows that they're owning a lemon is going to get a certification, it's going to say this is a lemon. So they really don't have any incentive to do that. The only people who have an incentive to do this are the ones that own good used cars, right? Because when they get their car certified, what's going to happen is it's going to say this is a good used car. This costs $100, so the willingness to sell now goes up. Previously, they wanted $700 per car that they sold. Now they want $800. They're going to, if they certify it, we're going to see what happens to the market. Now we're going to first look at prices that are less than $800, right? This is the new willingness to sell. Then prices of exactly $800. We're going to look at prices that are between $800 and $1,200. Yes, and $1,200. That's the willingness to pay. We're going to look at a price of exactly $1,200 and prices of above $1,200. We know there's all the owners of the good cars are not going to be willing to sell anything at a price of less than 800. At 800, they're willing to sell anywhere between 0 and 5 cars, and for all prices above, they're willing to sell 5. Demand, we know they're willing for a good car. This is a market with only good cars, so no adverse selection, no asymmetric information anymore. They're willing to pay $1,200 for it, so they're definitely willing to pay less than 800, so there's 25 in demand. And this is going to apply up to this case where the price is exactly $1,200, and for all prices above, they're going to pay 0. You again can use the surplus notion for this. We know their willingness to pay is $1,200, so willingness to pay minus price is positive. You could fill this in here. I'm going to skip this. I think it should be pretty obvious by now. And how do we find the equilibrium? Well, we compare the quantity sold to the quantity demanded. This one doesn't match, this one doesn't match, this one doesn't match, but this one does. So we know that the equilibrium in the market for certified good cars is going to be an equilibrium price of 1,200, quantity sold 5, quantity demanded 5 as well, or the demand is anywhere between 0 and 5 of them are just going to happen to get a car. Now let's look at the uncertified lemons. We're going to first look at prices that are less than the reservation value of 200, a price of exactly 200, a price that's between 200 and 400, that's the willingness to pay, price of exactly 400, and prices above $400. Supply below 200, no one is willing to sell their lemon. At 200, it's anywhere between 0 and 5 because they're indifferent between selling and not selling. Sorry, 0 and 15. And then it's going to remain 15 thereafter. Quantity demanded, well, it's going to be 25 up to a value of 400. Then it's between 25 and 0 in the end. Now we compare quantity supplied, quantity demanded. Doesn't match, doesn't match, doesn't match. Matches. And we have found that if there is this mechanic moving into the town and offering the service, we can theoretically get an equilibrium of $1,200 in the market for certified good used cars and a value of $400 for the lemons. The last thing we need to do to make sure that this is actually an equilibrium is we have to make sure that the surplus, the total surplus for the owners of good cars and lemons respectively to the question 1 is higher, or at least as great. So how much money do good car owners total value and lemon owners total value? Let me drop the apostrophes. So the good car owners, we know they're going to sell 5 cars. They're going to get $1,200 for them. They have a reservation value of 700, and they need to pay the mechanic 100. So they get 2,000. If for the lemon owners, we know that there's 15 of them. They are going to get 400 for their cars, and they have a reservation of 200. They don't pay the mechanic, so in total they make 300. Or if you want it on a per owner basis, it's 400 for those of good cars and 200 for those of bad cars. Now we're going to look at, well, what happened in the first setting. Well, in the first case, we know that there was an equilibrium of 400 where all the lemons were sold and none of the good cars. So the good car owners actually got nothing. They held on to their cars. They were not making any money, so to speak. The lemon owners, well, again, there was 15 of them. They sold at 400 and they had a reservation value of 200. So you can see lemon owners are equally happy with or without the mechanic, but suddenly all the good car owners are going to be able to sell their cars, so we're generating a lot of value there, and this means that this equilibrium can be supported, namely that no one is better off by not going with a mechanic. And obviously you can easily see that even in this setting, it's always bad for the owners of lemons to try to get a certification because they waste $100 on that, and it's going to say it's a lemon, so they're never going to do this. Similarly, going back, we know that for the owners of the good cars, it's not worth it to not pay for the certification, because if they not pay for the certification, they go back to exactly this case where they don't sell anything because the cars are going to be indistinguishable. All right, I hope this made it clear. Well, I'll see you on the next one.